This morning we're going to be looking at solving simultaneous equations using matrices. These examples are pretty trivial, but what you're going to see is that this can become a very powerful tool where you have multiple equations and multiple unknowns. Now remember that you need to have the same number of unknowns as you have equations in order to solve for those unknowns. We have two unknowns, two equations, and we are going to put these into matrices. What I'd like you to notice is that if we put the coefficients of our variables into a matrix, we get a matrix that looks like this. So we're going to let A equal 4, 5, 3, and 2. Notice that the unknowns or the coefficients for x are all in column 1 and our coefficients for y are all in column 2. Now let's make our unknown matrix, or the values that we're wanting to find, the variables for the values we want to find, be our x matrix, and we'll say that's x and y, and then our solution matrix will be B, and that's 6 and 8. Now if we put that into an equation, what you're going to see is something that you should recognize, because if I multiply my A matrix by X, I should get my B matrix. Now we want to solve for X, so that means we need to multiply A by its inverse, and order matters with multiplication, so we're pre-multiplying our inverse, YA, and that means we're going to pre-multiply on the right-hand side of our equation. And remember that A multiplied by A inverse gives us our identity matrix, and so that then allows us to solve for X. Alright, in order to find our inverse of A, we need our determinant of A, and our determinant of A is just going to be AD minus BC, and that would be 8 minus 15, which is negative 7. Okay, so now our inverse will be 1 over our determinant of A, and we swap our A and D, and we have negative B and C. So that's going to be negative 1/7 to negative 3, negative 5, and 4. So that then means that our X is going to be negative 1/7 multiplied by 2, negative 3, negative 5, 4, multiplied by 6 and 8. Alright, so let's multiply. Before we multiply, we want to just double check that we have got the order correct. So this is a 2 by 2, that's a 2 by 1. Means that our answer is going to be a 2 by 1 matrix. Okay, so we're multiplying. We have 2 6s on 12, minus 5 8s, which are 40, and then negative 3 times 6, which is negative 18, plus 8 4s, which are 32, and that gives me negative 1/7, negative 28, 14, and because we're solving for x, we're actually going to multiply that 1/7 in, and we're going to get 4 and 2. And then we need to relate that 4 and 2 back to our unknown x. So therefore, remember, we can use equality of matrices if they are the same order as on both sides, and our matrix X was a 2 by 1, and our answer is a 2 by 1, so therefore X must equal 4 and Y equals 2. My apologies, grade 10s. The final answer over here should have a negative 2 in it, and Y should have a negative 2 in front of it.